All right. The fourth and final part to this gigantic section is about polynomial modeling. And this is going to rely heavily on our graphing calculators. Modeling just means use data to come up with an equation. And sometimes we do that with linear equations. We're given 2 points, and we could easily do that by hand. But when you have an entire table full of data, and you want to come up with this giant polynomial, it is extremely difficult to do that by hand, especially with just the information that we have now about algebra. It requires a lot more sophisticated techniques. So we're going to solely be learning how to do this on the calculator. So a model is just an equation that represents, as closely as possible, it's never exact, but just as closely as possible represents some real life data. And we might want an equation that represents this data so that we can make predictions. So if we knew how much milk was sold throughout the month, we might want to make a prediction about how much is going to be sold next month or the month after. So if we had this equation that's based on data that we've collected from trends, we could always use it to make predictions. So we're going to be taking some data and plugging it into our calculator and then asking our calculator to create a model. And we're going to be creating several models and comparing them to decide which one's the best one. So the very first thing I need you to do, in order to compare the models and decide which one is the best, we need to have our diagnostics turned on the calculator. And the way that we do that, and I have an old calculator. If you've got a newer calculator, it's going to be completely different. It's actually a little bit easier. But for my old calculator to turn on the diagnostics, I have to go to the catalog, which is second 0. And I have to go all the way down until I see diagnostics on. And these are in alphabetical order, so just scroll down to the D's. Once I see diagnostics on, I'm going to hit enter once. That's going to put it on my home screen. I'm going to hit enter again to actually turn the diagnostics on. So we need to make sure that the calculator has diagnostics turned on. I feel like I just spelled that wrong. No. Otherwise, we're not going to get all of the information that we need to decide which one of these models is the best. So I'm just going to do an example out of the book where they give us some data and ask us to find some different models that go along with it. So I'm going to move this to the side just so I can show you the data that I'm using. And it's actually on page 313, number 77. It says the number of foreign adoptions in the United States has declined in recent years, as shown in the table below. And the table they give us says year, and they give us an x value because we're not actually using the full year as our x coordinate. So in 2000, they say use year 0. In 2001, use year 1. 2002, year 2. 2003, so we see the pattern here. X is just how many years since 2000, and it goes all the way down to 9. And then they give us the number of U.S. foreign adoptions from the top 15 countries. And I'm just going to say adoptions here. And it gives us a number of adoptions for each year. So for 10 years, we collected data on how many foreign adoptions there were. And we could use this data to help us make predictions about what might happen in the future. And all I'm doing is I'm copying these numbers out of a table in the book. It's on page 313, number 77. Sorry. All right, just about done. I wrote these down just in case you don't have a copy of the book handy right in front of you right now. But the first thing they ask us to do is fit several different functions to this data. They want us to do a quadratic equation. They want us to do a cubic equation, and they want us to do a quartic equation. A quadratic equation is an equation where we have an x squared. And then a cubic equation is where we have an x cubed. And a quartic equation is x to the fourth. And we have all three of those options in our calculator. So step number one is to get all of this data from this table into the calculator. And the way that we do that is we go to the Stat button. And under Stat, you're going to go to Edit. And option number one is also Edit. This is where we enter data into the calculator. So I've got two lists of data, and these lists are linked. So year 0 is 18,120 adoptions. Those two have to go together. So I need to be really careful when I enter these lists into my calculator that nothing gets skipped or nothing goes out of order or anything like that. So I'm going to use my column L1 to enter all my x values. So it's just 0 through 9. So I'm just going to hit 0, enter, and it will put the 0 in there, and it will go down to the next entry spot. So 1, enter, 2, enter, 3, enter, all the way down to 9. And it's actually going to be 10 entries because we started with 0. So you notice when I have 9 highlighted, it says L1 parentheses 10. So it's the 10th entry. And this is a good way to check and make sure that we have the same number of pieces of data. If not, then something's missing. So I just pressed the right arrow button, and it moved me over to L2, and that's where I'm going to enter my second list of data, and that's the number of adoptions. And just be really careful that you don't skip anything or mistype anything, because it will throw your answer off. So the first one is 18,120. Hit enter. And then we're going to enter all of them. 19,087. Enter. 20,100. Enter. 21,320. Enter. 22,911. Enter. And so on until they're all in. So got 22,710, 20,705, 19,741, 17,229, and 12,782. And notice how my L2 column also ends at 10. So that's a good indicator that I didn't mess anything up. I've got 10 entries in column 1, 10 entries in column 2. So good. So now that all the data's in there, I'm going to go back to Stat, and now I'm going to do some calculations with that data. So I arrowed over to my calc list. And option number 5, 6, and 7 are what we're going to be using. 5, 6, and 7. Number 5 says quad reg. That's quadratic regression. When we use a specific method, we're doing regression to do these models. We specifically want a quadratic equation that matches up with this data. So if we choose option 5, the calculator will choose the best quadratic function that fits our data. If we choose option 6, it says cubic regression. The calculator will figure out the best cubic function that will fit our data. And then option number 7 says quart reg. That's quartic regression. And it will choose the best x to the fourth equation that fits our data. And we have to do them one at a time. So I'm going to choose option 5. All it does is put it on my home screen. And then we need to tell it where the data is. And I put my data in L1 and L2. And if you look really carefully, right above my number 1 and my number 2, In yellow, I've got L1 and L2. So I can hit second L1, comma, second L2. So now it says quadreg L1, comma, L2. So it's using L1 for my x coordinates, L2 for my y coordinates. And I'm just going to hit enter. Again, if you've got a newer calculator, it's going to be a little bit different. So to decide if this is a good model or not, what we're looking at is this r squared value. So for the quadratic regression, and I want to write this down because I'm going to use it to compare later, r squared is 0.9388 if we round it. The closer that number is to 1, the better. If it's equal to 1, that means these points fit exactly perfectly onto the parabola. Now, these points don't fit perfectly onto this parabola, but they're really, really, really close. So that's a really high number, really close to 1. So I don't care about the equation right now. I'm just comparing my r squares. So I'm going to go back again to stat, calc, and this time I'm going to do cubic. And I'm going to tell it my x's are in L1 and my y's are in L2 and hit enter. And it gives me a new r squared value, and that r squared is even better. So under cubic, because I'm going to be asked just a minute which one is the best, the cubic coefficient of determination, r squared is called the coefficient of determination, is 0.9783. And then I'm going to do it one more time because the directions said quadratic, cubic, and quartic. So stat, calc, quartic regression, that's option 7. And my data, my x's are in L1, my y's are in L2. Enter. And this one, there's a lot of information here because a quartic equation has 5 coefficients, and there's only so much they can fit on the screen. So I've got to hit the down arrow to see the rest of my information. It says r squared for quartic is 0.9815. So of my 3 options, that is the largest one, 0.9815. So the quartic equation is the best equation. So in option A, it said find all those models and figure out which function is the best fit. Quartic is the best fit because the coefficient of determination is closest to 1. And there's a part B to this as well. So this was just part A to figure out which one we like the best. And we like quartic the best. So now that we've decided which function we like the best, part B says use our best function to estimate the number of U.S. foreign adoptions in 2010. Now, if you remember, I just said that quartic equation has 5 coefficients, and they've got a lot of decimals in them. So there's a trick we can do here on the calculator. With the older calculators, I've got this, they tell you the format that the function's going to be in, and then they give you all of the values for A, B, C, D, E. Now you can write all that down if you want to and enter it into y equals by hand, but the fastest way to do it is with this on your home screen right now. Go to y equals, and I'm going to tell it to put my regression equation right there. So I'm going to go to vars. I'm going to go down to statistics, and I'm going to arrow over to equations, and I'm going to choose the regression equation. And it throws that entire quartic equation in there. And we're asked what's going to happen in 2010. And remember, our x is number of years after 2000. So now I can just go to my table and scroll down to 10. And it looks like there's going to be 8,404 adoptions.